Part 1. The Birth of a Tornado. Everything begins inside a severe thunderstorm, specifically a type called a supercell. These storms form when warm, moist air from the Gulf of Mexico collides with cool, dry air from Canada and strong upper-level winds. The mixture creates powerful instability and wind shear, meaning the wind's speed and direction change dramatically with height. This wind shear causes the air to start rotating horizontally, like a rolling cylinder in the sky. Updrafts within the storm tilt that rotation vertically, creating a rotating column of air known as a mesocyclone. Under just the right conditions, part of this rotation tightens and stretches toward the ground, and that's when a tornado is born. Part 2. The Eye of the Storm. Tornado Structure. To understand what happens inside, imagine peeling back the walls of a tornado like layers of an onion. At the very center is the core, the calmest and lowest pressure area. The air here is descending slightly, which might sound surprising since we often think of tornadoes as purely upward moving. Around this calm core is the vortex wall, a violently rotating layer of air filled with dust, debris, and moisture. Outside the main funnel are smaller, secondary vortices that orbit the main core. These mini tornadoes can cause streaks of extreme damage even within a single street. When you see videos of a tornado tearing through an area and some houses are completely gone while others remain standing, it's often because of these smaller, intense suction vortices. Part 3. Inside the funnel. The physics of chaos. If you could step inside a tornado, which you definitely shouldn't try, you'd experience unimaginable forces. Wind speeds inside a powerful EF5 tornado can exceed 300 miles per hour. That's stronger than the winds of most hurricanes. At these speeds, the air pressure inside the funnel drops drastically, sometimes as much as 100 millibars lower than the surrounding atmosphere. This sudden drop in pressure can make objects literally explode outward as the higher pressure inside them forces air to escape. It's also why windows sometimes burst outward during tornadoes, not inward, as people often believe. The rapid pressure change is like a violent vacuum ripping through everything in its path. Part 4. The Vacuum Effect. The lower pressure inside the tornado acts like a massive vacuum cleaner. This suction force can pull up lightweight debris, lift vehicles, and even uproot trees. But the most dangerous part isn't the suction, it's the debris itself. Once airborne, those fragments turn into deadly projectiles traveling at over 200 miles per hour. When people describe hearing a tornado as sounding like a freight train, that roaring noise actually comes from this mix of wind and debris battering everything around it. The sound is deafening and constant, growing louder as the vortex gets closer. Part 5. The Updraft. Nature's Elevator. Inside a tornado, air is constantly moving upward in a spiraling motion. This powerful updraft can carry massive objects thousands of feet into the air. There have been documented cases of pieces of houses, vehicles, and even livestock being lifted and dropped miles away. One incredible example occurred during the 1999 Oklahoma tornado outbreak, where radar detected debris lifted over 30,000 feet into the atmosphere, nearly the height of a commercial jet's cruising altitude. Part 6. Temperature and pressure extremes. While tornadoes form in warm, humid environments, the air inside the vortex is surprisingly cool due to rapid expansion. As the pressure drops, the air cools, leading to condensation that gives the funnel its distinct, ghostly appearance. That visible funnel is mostly made of water droplets and dust, illuminated by lightning or sunlight. In some cases, you might not even see the funnel at all. These are called invisible tornadoes, and they're often only noticed by the damage they leave behind. Part 7. Multiple vortex tornadoes. Some of the most destructive tornadoes contain not one, but several smaller vortices rotating around the main funnel. Each of these can have winds stronger than 250 miles per hour, intensifying the overall damage. These smaller vortices can appear and disappear within seconds, making the tornado's path of destruction highly unpredictable. That's why some buildings are obliterated while others right next door are only slightly damaged. Part 8. The debris cloud. Below the main funnel lies the debris cloud, a swirling mass of dirt, dust, and shredded material picked up from the ground. It's what makes the base of a tornado look darker and wider. The debris cloud is chaotic and constantly changing, with objects colliding, bouncing, and grinding together at terrifying speeds. In a sense, the tornado feeds on this debris, continuing to gain strength as it pulls more material into its circulation. Part 9. The life cycle of a tornado. Tornadoes don't last long. Most dissipate within 10 to 20 minutes. The life cycle goes through several stages: formation, maturity, and decay. During the mature stage, the tornado is at its most powerful, wide, stable, and extremely destructive. Eventually, the inflow of warm, moist air weakens and cooler air wraps around the circulation. The funnel begins to thin and stretch, becoming what's called a rope tornado. Soon after, it breaks apart and disappears, leaving a path of devastation behind. Part 10. Measuring tornado strength, the enhanced Fujita scale. To measure tornado strength, scientists use the Enhanced Fujita (EF) scale, which ranges from EF0 to EF5. Instead of directly measuring wind speeds, the scale estimates them based on the damage observed. EF0 to EF1, minor to moderate damage. Shingles ripped off roofs, small trees uprooted. EF2-EF3, significant damage. Roofs torn off houses, vehicles lifted. EF4 to EF5, catastrophic destruction. Entire buildings leveled, massive structures swept away. EF5 tornadoes are rare, but when they strike, they can leave scars visible from space. Part 11. What happens to the air inside? One of the most fascinating things about a tornado is how efficiently it transfers energy. Air from near the surface is pulled upward, rotating faster as it moves closer to the center, much like a figure skater spinning faster when pulling in their arms. This conservation of angular momentum is what makes tornadoes so powerful. It's the same principle that drives hurricanes, ice skaters, and even galaxies, just on a much smaller, deadlier scale. Part 12. Myths about the inside of tornadoes. There are a lot of myths about what happens inside tornadoes. One common belief is that the center is perfectly calm, like the eye of a hurricane. In reality, that's not true. While pressure is lowest in the center, wind speeds remain dangerously high. Another myth is that opening your windows during a tornado will prevent your house from exploding. That's completely false. It wastes precious time and can actually make things worse by allowing debris to enter your home. The best thing you can do is get to a basement or an interior room with no windows. Part 13. Can you survive inside a tornado? Surviving inside a tornado is extremely unlikely, but not impossible. There have been rare cases of people being thrown hundreds of feet and surviving with serious injuries. However, these are exceptions, not the rule. The forces inside the vortex are too violent and the debris makes survival nearly impossible. Tornadoes don't just blow things away, they destroy, shred, and pulverize.